And now for this next question. I know that James has a lot to share with you. We've discussed things from going from source code into going to the AST, into generating bytecode from the AST. But what's up with the interpreter, James? How do we go from bytecode to actual machine instruction? What does that even do? What does that mean?
Why don't we take a look at something that I encourage every single one of you watching to follow along and actually do. It's something that we don't do very often, but once we build up the habit of doing, we can discover is an incredibly powerful technique for really understanding what Python does under the covers, how the interpreter actually works. What we're going to do is we are going to build Python from source with debugging symbols, and we're going to try and set some Python interpreter level debugging breakpoints and use that to understand what the mechanical steps of the interpreter themselves actually are. Here's the story. I started learning Python by reading through documentation. I read through a bunch of blog posts, I read through a bunch of tutorials, I read through Stack Overflow in the very early days of Stack Overflow. At a certain point, I discovered that, well, Python 2 versus 3, so is this blog post really up to date? Oh, this seems to be somebody's kind of rough approximation of how they believe something works, and these two blog posts don't exactly line up. One person is talking about details, the other person isn't really talking about who's actually correct. And at a certain point, I kind of got fed up, and I thought, can I answer these questions for myself? Can I go to the authoritative source, the source code itself, and figure out how the interpreter works? And once I discovered how to do that, and once I integrated that activity into my general debugging approach, I never looked back. To be honest, these days, I barely read through blog posts or documentation. I go straight to the source and I can answer the question directly. However, one of the caveats for how this process actually plays out in the real world is the source is very large. There's 600,000 lines of CPython source code, just .c files alone. And you're not always going to be able to find things that you want to find. Why don't we take a look at how to build Python from source? We'll get as far as we can, and for those of you who are in the VIP session, we'll provide you with an additional supplementary video, which will show you a couple of questions that you can answer by looking at the bytecode itself. But in order to do that, why don't I share your screen, Cameron, and we'll take a look. And so behind me, you should see Cameron's screen one more time, and of course, I'll also hide in the corner here. And Cameron, the very first point to start whenever you're going to build anything from source, well, you have to check this out from GitHub. And so why don't we just start by checking out CPython from GitHub. I really strongly encourage everybody to follow along as I go through these steps, because we'll be doing them live, and because until you build up that muscle memory, that habit of doing it, it's very easy to never actually get around to doing these steps in your own work itself. And so what I'll do is I'll clone GitHub, Python, CPython, and anytime I have, and by the way, I'm not even going to do it that way, just to save us some time, I'll do a shallow clone. So I'll just grab the latest commit, because I don't really care about anything historically. I don't care about anything prior to the most recent commit. Now, once we have this, we'll go into our CPython directory, and we'll actually build this from source. One of the things that surprised me when I first saw Python was I had been writing C and C++ code, and I had been dealing with really complex, non-standard build systems. CPython has basically the most standard make-based build system with one or two aspects of kind of special things that it does relating to things like frozen modules and also generating the grammar from a grammar definition and a couple of other small details here. But for the most part, you can follow your standard config, make install, and everything will work. Now there's one thing that I'm going to do. I'm going to set a couple of C flags, and there's a reason for this. Cameron, I don't just want to build Python from source. I want to build it with debugging symbols. I want to build it so I can set a breakpoint and I can answer questions. And the more information I can answer, well, the more information I have, the more questions I can answer, and so I want to make sure that all that information is preserved. So I'll set G, G3, GGDB, and G dwarf 5. And I'll turn off optimizations. And one of the reasons why I want to turn off optimizations is when you're reading through C source code, you want to be able to read through it line by line and see the line by line execute. And if you have optimizations, the C compiler might reorder these lines. Well, that's going to make it harder for us to understand what's going on. So we'll just turn off all optimizations. That means that what we're going to see here is going to be a very close approximate to how your optimized build in Python works. But these are optimizations, Cameron. They're supposed to be equivalent to the unoptimized form. So hopefully that's not a big deal. Now, let me set a prefix for where to install this. So I'll install this to your home directory, and I'll enable 2 other flags. I'll enable the shared object, and I'll enable a with PyDebug, which will add a couple more debugging symbols. The entirety of this process should take about 90 seconds. And so, Cameron, you ever built anything from source?
Yes, I have, but I will admit, I was just, it was just a make install, and and then when it didn't work, it was okay, well, gotta go find this build tool chain. Okay, install that and make install again. Oh, thank goodness it ran.
One of the nice things about CPython is it's generally pretty easy to build these from source, at least if you have a Linux machine. And so one of the advices I would give you regarding this process is, if you are on OS X or if you're on Windows, maybe don't worry too much about getting the build chain and all the build tools installed. Just use a simple VirtualBox virtual machine, a Docker-based virtual machine as well, or maybe grab an AWS or DigitalOcean droplet, like a $5 droplet, and just build it on a standard installation of Ubuntu. In general, on the latest version of Ubuntu, this build will more or less just succeed. You might be missing 1 or 2 dependencies, but other than that, it should just work. Now, the next step I'm going to do is I'm going to actually build it, and I'll show you one little trick that I'm going to do. I'm going to build this in parallel, and I'm going to get how many processors this machine has that are online. So is it get config? No. It's get conf. There we go, and I'll use that just so that we get a nice parallel build. And this process here should take another minute or so. Let's time this while it builds everything. One of the useful things that you can see when you build a Python interpreter is Python is not a truth of the universe. It's just a C program that some folks wrote that takes input and generates output. It's every step of everything that is done in a Python interpreter is written in some .c file somewhere. You ever curious about the internal workings of a list? There's a list object.c in the CPython source code. You ever curious about what happens when you are executing the bytecode? As we saw, you can investigate via dis.dis. There's just a file python ceval.c, and that will show you the step-by-step of what actually happens. Are you curious about, why do I have this limitation? I'm pretty sure I can fix this problem. Go through the source code, patch it, hopefully upstream it, maybe go through the PEP process if it's a complex patch, but it's a program that you can investigate, that you can read through the source code, that you can build yourself without having to do anything fancy. Now, this should wrap up in just a moment. And one of the things you can see is the build process here is relatively fast, and it's actually relatively sane. Here you can see it's now going to just the last step, and in a moment you can see this last step with all of these .o files was building that one Python executable. And so we should be just about done. Now, the last step of this, which is going to take just a bit of time and is a little bit annoying in terms of how much time it's going to take, is we have to install this, which means copying over a bunch of .py files and generating py cache, the cached bytecode and whatnot. And so let's give this just a moment to wrap up, then we'll make install. One way we're going to speed this up is we're going to send all the output to dev null, just so that we don't have it spam the screen and slow us down. And then we'll actually be able to do something kind of interesting here. While we're doing that, I want to show you just a very quick overview of what the CPython source code actually looks like. Here you can see the source code for CPython. There's a couple of different libraries here, or there's a couple of different folders here. There's only a couple of these that are actually of interest. If you look at the CPython source code, it is absolutely just very, very easy to become overwhelmed. Let me show you something. Cameron, let's see how many .py files are in the standard library. Oops, let's do type f name. I guess we'll do an iname here. Okay, so let's see how many of those there are. Approximately 2,000 .py files in the standard library. Let's see how many lines of code there are. Is that surprising to you, Cameron?
Oh, man. Yeah, that's. I was saying over 600,000. This is 911,000.
Of just .py files, and that of course includes tests, it includes some of the tools. If we just look at the standard library itself, which would be most of the things in this lib directory, we can see, and let's actually do this correctly, we can see 842,000 lines of code, more or less, in the standard library, but this also includes the unit tests. So maybe just shy of 800,000 lines of code. If we look at how much C code is in the Python interpreter, 642,000 lines of C code. Now, let's do the back of the envelope math. I can read about 6 lines of C code an hour. So how many hours, days, years, decades, or millennia will it take for me to read 642,000 lines of code? It's going to take me a lot.
It's a very long time.
The general trick, and what we will show you in the backstage session, is whenever you're doing anything with these packages, one of the most critical debugging steps is figuring out how to quickly find what you care about. So I'm just going to quickly launch a debugger using GDB, and then we'll wrap up. But one of the tricks to this is there is no way you're going to step through 600,000 lines of C code and 842,000 lines of .py code to find anything interesting. You have to discover techniques and tricks to quickly narrow down and to isolate, this is the part that I care about. And so, just to get this running, I just want to set my path. This would be CPython bin with whatever is in my path. And because I built this with a shared object, I need to set one more environmental variable, LD library path. And here, this can be pwd, python lib, and then whatever is in my LD library path. And then we'll launch this with GDB. Now, let me just fix these two paths here. I'll launch GDB. I'm going to give it one or two very simple arguments, nh and -q, just to stop it from spamming my screen with some extra stuff. I'm going to give it one more argument, ex, which is just going to execute a script that comes with the CPython source code. So let's go, this is source, CPython, tools, GDB, lib, Python, and this will add us a little bit of extra debugging information for us. And then, let's see what happens. Let's run our Python interpreter. Hey, we have a Python 3.12 install that's running. If I Control C, and I do a BT for backtrace, this is the actual process of how the Python interpreter works. You can see there's some read line technique that's reading each line. It's tokenizing that line. This is being called from the parser. You can see all the way down to the actual entry point, python.c in the programs directory. There is an actual main function that called pybytes main that calls everything that we use. And you can see, having built this with all of these debugging symbols, including that with pydebug and sourcing that special file that's provided in the Python installation, the tools, GDB, lib, Python, we can even see information like what the Python objects are passed in, what their representations are, what their IDs are. And let's try something. Let's put a break on a pi number multiply, Cameron. Let's continue operating. Let's actually pi number multiply 1, 2, 3 times 4, 5, 6. Let's look at the backtrace for this, and we can see a multiplication that's occurring as part of the AST optimization. This is the constant folding you were telling people about just a moment ago.
You see the bin op right there on line number 2.
Yeah, right there. And so if I continue and I create a class T, and I create 2 instances of this class, and I multiply these, I see that pi number multiply occurring in a different context, in the evaluation context. I can't constant fold this on this class. Here I can actually dive down and immediately get a sense of what steps are running where, and the entire chain of operations all the way up in the interpreter.